Meet me at Anchor Way and Commodore Road. At one time or another, most of us have identified a location in this way by referring to the intersection of two streets. Or we have said, I live between Commodore Road and Galley Boulevard at 310 Anchor Way, and thus precisely located the house. In a city with clearly identified streets, this method of giving a location works well. The streets and street numbers are easily recognized points of reference by means of which exact locations can be described. But how do you accurately describe locations in a foreign land or in a non-populated rural area? No street signs here, not even streets. Yet if a soldier is to function properly, he must be able to find his way efficiently from one position to another anywhere in the world. And to accomplish this, he must have some means of identifying the location of objects or points of reference on the ground in a uniform and precise manner. These men, for example, are in an area previously unknown to them. They have just completed a reconnaissance mission which has brought them to this location. Now they must rejoin their patrol along a road several thousand meters distant at a designated but unmarked point. Without prior knowledge of the area, how can these men find their way precisely and efficiently to a destination they can neither see nor identify? The military map provides the answer, but the men must be able to utilize the information it contains. As you know, a map is a drawing to scale of a portion of the Earth's surface on which natural and man-made features are depicted by symbols, lines, and colors. In addition, a military map is a topographic map which shows both relief and the horizontal position of all features in measurable form. Thus it presents a precise, detailed, and accurate picture of the area it covers. If the military map is to be really efficient, however, it must include some practical means of locating points at any place on the map or on the ground. Thus, medium or large-scale military maps, like this standard 1 to 50,000 scale map, are overprinted with an orderly system of lines called a military grid. Because of its relative simplicity, the Army uses this grid system for the expression of location. A grid system consists of two sets of parallel lines intersecting at right angles and forming a series of squares which are equal in size. The lines running horizontally head approximately east and west, while the vertical lines run north and south. It is obvious that this system of squares will enable one to locate a point by stating within which square the point lies. So for purposes of identification, each line is numbered along the edge of the map, as well as within the map itself. Like a well-marked city street, each line is clearly marked and can be used in locating any grid square which borders it. You may have noticed that the line numbers printed at the edge of the map contain small figures not found in connection with those printed within the map itself. These small figures are included primarily to relate this map to others of adjacent areas. When using the military grid system to locate a position on the map, they should be ignored. Use only the large numbers, which are called principal digits. Forget all others. Keeping this precaution in mind, let us see how the grid system is used to locate a position on the map. As an example, a farmhouse is situated here. How would the area or grid squares within which it is located be designated? By what are called coordinates, made up of numbers derived from the grid lines adjacent to the square. Coordinates are written as one number, but always contain an even number of digits. On the military map, the first half of these digits is always read to the right. The second half of the coordinates is always read up from the bottom. This is the first and most important thing to remember in using the military grid. Always read right and then up. Or it may be easier to remember read right up whenever interpreting grid coordinates. Now let us see how this rule applies in pinpointing the farmhouse. Starting at the left edge of the map and reading to the right until we arrive at the first grid line which borders the square with the farmhouse, this is grid line 05. These become the first two digits of the coordinates which will identify this grid square. Again, starting at the lower edge of the map, read up, arriving at the grid line bordering the lower edge of the square. This is line 64. These digits complete the coordinates which identify this grid square as 05, 64, lying to the right and up from the point where the grid lines 05 and 64 cross. The other grid squares are identified in the same manner. Read right and up to find the proper designation. For military operations or reporting purposes, however, grid square identification is not precise enough. On most military maps, the space between the grid lines, known as the grid interval, is 1,000 meters. The grid square represents an area large enough to accommodate many features in addition to the farmhouse we wish to pinpoint. So a more exact position is necessary. To accomplish this, the grid sides are divided into tenths, either by eye or by means of a coordinate scale. When this has been done, we can see that the farmhouse lies 7/10 to the right of line 05 and 8/10 of a square up from line 64. These fractional indicators are integrated into the grid square number by keeping in mind that the first half of its digits are read to the right. Thus, the first half of the coordinates now becomes 05 plus the number of tenths, 7. And the second half, reading up, becomes 64 plus the number of tenths, 8. The final number 057648 represents coordinates which locate the farmhouse to within 100 meters. This is how the grid system enables you to describe or find the location of features at any point on the military map accurately, clearly, and easily, if you will remember to read right up. To aid you in using the grid system, every military map carries instructions describing the method we have just seen demonstrated. These are found here in what is called the grid reference box. The grid reference box is divided into two parts. The left portion contains information identifying the map and the area it covers. At the bottom, it carries a reminder to ignore the smaller figures in any printed grid number and use only the large figures in plotting locations on the map. The right part of the box explains how to use the grid in giving or locating a standard reference on the map with an example of the method we have just observed keyed to a point on the map. In brief, the grid reference box contains the operating instructions for the military grid system. By consulting it, you will be able to use the grid successfully when you find yourself in a situation like this. As you remember, these men have just completed a reconnaissance mission through an area they have not known previously. Now they must rejoin their patrol at a point some distance away, identified only by this number we now recognize as grid coordinates. How will they do this? We know that grid coordinates are written to be read right, up, and that the first half of the digits is read to the right. Using these coordinates, the men will begin at the lower left-hand corner of the map and read right until they reach line 16, which is indicated by the first two digits of the coordinates. The third digit tells them that the location they are looking for is 1/10 of a grid square to the right of line 16, so a tick mark will be made at that point, and the next step is to read up. The following two digits direct the readers to move up to line 64, this one. The final digit indicates that the location is 6/10 of a grid square up from this line. This is marked off, and the men locate the point of rendezvous designated by the coordinates 161, 646. As you can see, by properly using the coordinates on the military grid, the rendezvous point has been located efficiently, clearly, and precisely. And its relationship to the present position of the map readers has been accurately plotted. With this essential information available, the men can now plan the route they will follow to rejoin their squad at the designated location. Between any 2 points on the map, there are usually several possible routes, and in selecting the most suitable, relative distance should be among the first considerations. With a military map, the determination of ground distance between 2 points is a simple matter, thanks to the graphic or bar scales which are printed on each map. These are in effect rulers by means of which distances on the map may be measured as actual ground distances in terms of statute miles, meters, yards, or nautical miles. Their use is easily understood. For example, this is how you determine the straight line ground distance between 2 points on the map. Lay a straight-edged piece of paper on the map so that its edge touches both points. Make a tick mark on the edge of the paper at each point. Then move the paper down to the appropriate graphic scale and read the ground distance between the 2 points. The graphic scale is divided into 2 sections. That to the right of the 0 is called the primary scale and is marked with full units of measure. From this primary scale, we see that the straight line ground distance is more than 3,000 meters. How much more can be read to the left of the 0 on what is called the extension scale? This is divided into tenths of a unit, and in this instance shows the total distance to be 800 meters more than the 3,000 on the primary scale, or a total of 3,800 meters. This is how the straight line ground distance between any 2 points on a military map is determined. To measure distance along a curved line, like a stream or winding road, the straight-edged paper is again used. Make a tick mark at or near one end of the paper and place it at the point from which the line or route is to be measured. Then align the edge of the paper along the first straight portion of the route. Make a tick mark on both map and paper at the end of the aligned portion, and keeping both tick marks together, pivot the paper until the next straight portion is aligned. Again make a tick mark on both map and paper, and continue in this manner along the entire route, taking care to keep the tick marks aligned at each change of the paper's position until the measurement is complete. Then move the paper down to the appropriate scale and read the total distance between the 2 points on the map. When the marked distance is greater than the length of the graph, it is measured in sections. In this case, we need 2 sections of 4,000 meters each, plus an additional 200 meters on the extension scale, for a total of 8,200 meters. This is how ground distance along a winding route is determined on the military map. In this example, the highway distance is much greater than the straight line distance. A more direct route to the rendezvous point is desirable. The map suggests several alternate possibilities, but although a route may be direct, if it leads across steep hills or up against deep bluffs or into similar obstacles, it is obviously not suitable. So before selecting a route, these men will carefully study their map to avoid such problems. On the military map, elevation and relief features are indicated by brown contour lines, which represent imaginary lines on the ground, along which all points are at the same distance above or below sea level. The vertical distance between these lines is called the contour interval, and on military maps is shown in the marginal information. The contour interval is always in a round figure, such as 5, 10, or as here, 20 feet. It is normally constant throughout the area of the map. In designating contour lines, sea level is always considered zero contour. Always remember that elevation means vertical distance from sea level, the same thing as height, and that every point on one contour line is at the same elevation, following all the curves, bulges, and dents in the ground surface. A contour line may wander all over the map, but it always represents the same elevation. With this basic explanation of elevations and contour lines, let us now see what relief features they can identify for us. For example, when contour lines are evenly spaced and wide apart, like this, they indicate a uniform and gentle slope. You can walk up such terrain easily and rapidly with a minimum of effort. When the contour lines are closely and evenly spaced, however, a uniform steep slope is shown. The closer the lines are together, the steeper the slope. A steep slope can be awkward and tiring to traverse, and in planning cross-country routes, such conditions should be avoided whenever possible. When contour lines converge or run so closely together that they merge into a single line, commonly called a carrying contour, it indicates a cliff at that location. Obviously, you want to avoid this, and a careful study of your map will enable you to do so. Lines spaced closely together at the top of a hill and wider at the bottom show a slope to be concave. A concave slope is hollow and has visibility features that can be important in combat situations. If you're on the side or top of a hill and there's an enemy at the bottom of its concave slope, you can see him and he can see you. Thus, when you need cover and concealment, remember that contour lines closely spaced at the top of a hill and wide at the bottom indicate a concave slope. The reverse is true when the lines at the top of a hill are widely spaced and those at its bottom are close together. Such an arrangement of contour lines depicts a convex or bulging slope, the opposite of what we have just seen. From the top of a slope like this, there is quite an area below the bulge which will be hidden from view. For the enemy or for yourself, this means natural concealment from observation. In planning movements under combat conditions, remember that a convex slope, shown by widely spaced lines at the top and close ones at the bottom, means poor visibility from above the bulge. When contour lines are spaced well apart and form a series of widely spread V's, a valley is indicated. A valley is frequently the result of the cutting action of a river or stream, and its bottom usually will offer low and reasonably level ground for passage or the limited maneuvering of small military units. A series of sharp V's, however, indicates a draw, a stream course that has not developed into a valley. The military difference between a valley and a draw is in terms of movement. A valley has enough reasonably level ground to permit the deployment of a military unit. A draw like this one does not. There are other topographic features, both natural and man-made, which can be identified by contour lines. Closed lines, for example, represent a hill. By studying the shape of these lines, you can readily visualize the actual hill they depict. When contour lines form a series of U's with their open ends pointing toward high ground, a ridge is indicated. This is a very short ridge. Others may be miles long, winding, or straight. But whenever you see the contour lines forming a series of U's with their open ends pointing to high ground, you can tell they represent one end of a ridge. When two hills or a ridge and a hill are enclosed by the same contour line, it indicates a saddle. As a general rule, a saddle is a noticeably low point along the crest of a ridge. Such a formation is important since it provides the easiest way of crossing a ridge. These closed contour lines, with tick marks pointing in, represent a depression in the Earth's surface. If tick marks are used on contour lines, they always appear on the downhill side of the contour. You should remember that for a depression to be shown on a map, it must be large enough to appear to scale. When contour lines form straight lines parallel to a man-made feature, such as a road or railroad, it indicates a cut. Modern highways could not be built on level grades without cutting through hills like this. Here tick marks are used, but pointing away from the contour line which parallels the road. This means that the roadway has been built up above the surrounding level by what is called a fill. Whenever a straight and parallel contour line adjacent to a man-made feature passes over a small stream, gully, or depression, a fill is indicated. Tick marks point toward the bottom of the fill. These, then, are some of the topographic features which contour lines will indicate on the military map. With these features in mind, let us now see what route these men have chosen to their rendezvous point and why. They have decided to move away from their present location and cross the medium-duty hard surface road to this stream. Then they will turn left and head upstream along its smooth and gently rising valley. Keeping the high ground before them, the men will follow the stream to its source, approximately 150 meters from this unimproved dirt road. They will follow this dirt road to the hard surface road, and then turn left and be within 200 meters of their destination. At no time along this route will any major topographic obstacles or obstructions be encountered. Thanks to their careful study of their map, the men know that the way they have chosen will be as easy as walking along a road and shorter. This is typical of the information your military map can give you, information that will get you to your destination precisely, efficiently, and safely. In combat, the ability to read and interpret a military map may well mean the difference between life and death, and the only way you can acquire this ability is through study, practice, and experience. Remember that coordinates identify a location on the military map and are written to be read right, up. The first half of the digits read to the right. The second half read up. Using these coordinates as an example, you begin at the lower left-hand corner of the map and read to the right. using only the large numbers until you arrive at the line indicated by the first two digits, 1-6. The third digit tells you that the location you seek is 1/10 of a grid square to the right of line 1-6. So you make a tick mark at this point and are ready now to read up. The next two digits direct you to move up to line 6-4. The final digit indicates that the location is 6/10 of a grid square up from this line, so you mark this off and locate the point designated by the coordinates 161-646. Learn to use this fast, simple, and precise method of locating points on the map, and you will have taken a long stride toward mastery of the military map. In map reading, remember that you can determine the ground distance between 2 points by marking the map distance between these 2 points on the straight edge of the paper, and then reading the ground distance directly from the appropriate scale in the lower margin. Also learn the purpose of contour lines and how to recognize the common topographic features they depict. Know that when contour lines are evenly spaced and wide apart, they indicate a uniform and gentle slope. But when contour lines are closely and evenly spaced, they represent a uniform steep slope. Remember, the closer the lines, the steeper the slope. Here, where the contour lines run so closely together they touch, they indicate a cliff. Keep in mind also that contour lines show the shape of a slope. When spaced closely at the top and wide on the bottom, the slope is concave or hollow. When widely separated on top and close at the bottom, the slope is convex or bulging out. An evenly spaced series of wide V's portrays a valley, wide and smooth enough for easy movement. On the other hand, sharply pointed V's indicate a draw. Once you have learned how to read and interpret contour formations, as well as how to use the military grid and the measurement scales, you will come to appreciate how in time of need, the military map can truly be a soldier's best friend. To scale of a portion of the Earth's surface on which natural and man-made features are depicted by symbols, lines, and colors. In addition, a military map is a topographic map which shows both relief and the horizontal position of all features in measurable form. Thus, it presents a precise, detailed, and accurate picture of the area it covers. If the military map is to be really efficient, however, it must include some practical means of locating points at any place on the map or on... Meet me at Anchor Way and Commodore Road. At one time or another, most of us have identified a location in this way by referring to the intersection of two streets. They have just completed a reconnaissance mission which has brought them to this location. Now they must rejoin their patrol along a road several thousand meters distant at a designated but unmarked point. Without prior knowledge of the area, how can these men find their way precisely and efficiently to a destination they can neither see nor identify? The military map provides the answer, but the men must be able to utilize the information it contains. As you know, a map is a draw locations in a foreign land or in an unpopulated rural area. No street signs here, not even streets. Yet if a soldier is to function properly, he must be able to find his way efficiently from one position to another anywhere in the world. And to accomplish this, he must have some means of identifying the location of objects or points of reference on the ground in a uniform and precise manner. These men, for example, are in an area previously unknown to them. Or we have said, I live between Commodore Road and Galley Boulevard at 310 Anchor Way, and thus precisely located the house. In a city with clearly identified streets, this method of giving a location works well. The streets and street numbers are easily recognized points of reference by means of which exact locations can be described. But how do you accurately describe